Welcome to our lecture on fiber optic cables, fiber connectors, and standards. Today we'll explore the world of fiber optics, its applications, and the standards that govern these technologies. This is crucial because fiber optics often is the backbone for most modern high-speed networks as it offers unparalleled speeds and reliability. By the end of this lesson, we should be able to summarize key Ethernet standards relating to fiber optics and understand the different types of fiber optics cables and their connectors. This knowledge will help you design and maintain high-performance networks. So to kick this off, fiber optic cables, unlike copper cables that use electrical signals, they use fiber optic light pulses to transmit data. This allows for a faster speed and longer distances. These are some of the standards for the Ethernet standards for fiber optics. Again, remember the number before is the speed, and more than likely you'll see like an F, an S, or an L for the fiber optic cables. In this case, 100 base TFX uses multi-mode fiber and supports 100 megabits per second. 1000 base SX and 1000 base LX use multi-mode fiber and single-mode fiber, but they support speeds of 1 gigabit per second or 1000 megabits per second. Same thing for the 10G base SR and 10G base LR. They both support speeds of 10,000 gigabits per second, well, 10,000 megabits per second or 10 gigabits per second. The primary advantage of fiber optics is higher bandwidth and longer distances compared to copper. Fiber optics cable transmits data using light pulses, which travel faster and suffer less signal degradation. Fiber optics are used exclusively in LANs or as the backbone cabling, telecommunication networks, and in some data centers. The core of fiber optic cable is made of an ultra pure glass, or it could be plastic as well. This cladding reflects the light back into the core, and the buffer provides physical protection. The difference between single mode and multi-mode fiber. So single mode fiber, or SMF, has a small core that allows one light mode to pass through a suitable length and is suitable for long distances and high-speed broadband networks, whereas multi-mode fiber has a larger core allowing multiple light modes, which is best for short distances like data centers and LANs. Single-mode fiber generally is more expensive but offers better performance for long distances and high-speed applications. For fiber optic connectors types, right, there are several different types of fiber optic connectors. SC or subscriber connector is a squared shape connector that is used in telecommunication networks, whereas LC, which is a lucent connector, is smaller and is ideally for high density installations, whereas the straight tip or ST is older but still used in some LANs and some data centers with a twisted lock. Each connector type has its unique features that are suited for different applications. For the wavelength division multiplexing, or WDM, which allows multiple data channels to share the same fiber using different wavelengths of light. It's like having multiple lanes on a highway for different data streams. There are two main types, one of them being CWDM, or the coarse wavelength division multiplexing, which is simple and more affordable, is used for shorter distances. The other one, which is the DWDM, or dense wavelength division multiplexing, which is a little more complex and supports higher capacity and longer distances. The wavelength division multiplexing increases the efficiency and the capacity of fiber optic networks by allowing multiple signals to travel simultaneously.